For more information, please visit SGMAK Associates website.
In this module, I'm going to explain two important concepts. One is how to relate nominal and effective interest rate, the difference between nominal interest rate and effective interest rate, how they relate based on the compounding frequency. And I'm also going to introduce the concept of capitalized cost in the second slide. So let's go through this example. You have invested $1,000, earning 12% per year. So future value after 1 year, you add 12% interest, that becomes $1,120. The compounding frequency, once a year, I'm representing it by M. M is 1. And I sub E, effective rate, is 12%. On $1,000, you got $1,120 after 1 year. Effective interest rate is 12%. Now let's say you're earning 12% per year, but you're compounding every 6 months. That means you're compounding twice a year. So first 6 months you get interest on $1,000, and so you have a new amount, and then that amount earns again interest on the remaining 6 months. So in this case, your future value becomes 1.06, because 6% is the interest per 6 months. So it becomes 1.06 raised to the power 2, because you have a compounding frequency of 2 twice a year. And your rate per time period is 6%. So future value becomes 1.06 raised to the power 2 multiplied by 1,000. And that number comes out to be, so we can get the corresponding number for that. Now, if you are using 12% per year and compounded quarterly, nominal rate per year is 3%, and your effective rate after 1 year becomes 12.55%. Now it is 1.03 because there are 4 quarters, raised to the power 4, 3% per quarter. Following the same logic, if I have a compounding frequency of 12, that means my rate per month is 1%, and I have 12 compounding period, then future value of $1,000 becomes $1,126.8 after 1 year. So effective interest rate is 12.68%. So as you can see, effective rate depends on the compounding frequency. It goes up as the compounding frequency goes up. One more example, simply, if you have weekly compounding, so your compounding frequency is now 52, and you get effective rate of 12.73%. So we can generalize the result now by combining these examples. If R is the nominal rate per year, M is the compounding frequency, so the nominal rate per period becomes R over M, and your effective rate becomes 1 plus R over M, summation raised to the power M minus 1. So R is the nominal rate, M is the compounding frequency, and as M increases, you are compounding more during the year. You're changing from yearly to 6 months to quarter to month to week. When you go up to daily rate, we didn't compute that. So I effective is 1 plus R over M within the bracket raised to the power M minus 1. So the relationship between effective and nominal interest rate. I said we have another important concept called capitalized cost. Capitalized cost, the simple meaning is if you have a cash flow that represents cost and that runs forever, a long period of time, what is the equivalent present value of that cost? That's a very simple concept. So you want to fold that into an example. What initial investment will support a recurring annual expenditure of $2,500 forever? The keyword in capitalized cost problem is the term look for forever. So you got a planning horizon is infinite. So what initial investment will support a recurring annual expenditure of $2,500 forever if the fund earns 6% during the first 5 years and 8% thereafter? So you got a mixed earning rate problem here. The planning horizon is infinite, but you have put money in an investment that give you 6% APR first 5 years, then it increases to 8% thereafter, and you are withdrawing $2,500 per year from this investment forever. You want to find out, if you look at the cash flow diagram, A is the annuity that you're withdrawing every year, $2,500. Was the value of X, and we have shown first 5 years 6% rate and then 8% thereafter. Let's first compute what is the value of the fund you have end of 5 years. You have made 5 payments. Your initial investment was X. So here's an expression: X times F over P, 6% 5 minus 2,500 times F over A, 6% 5. So the first term represents the future value of the initial investment after 5 years, and the second term represents future value of amount withdrawn at the end of 5 years. So that gives you how much money left from the initial investment. And you use table lookup to get the retrieve values for those factors, and the remaining balance, the value of the fund end of 5 years, I represented here as A prime, as given by 1.338x minus 1,409 2.5. Now this is the main principle of capitalized cost, which simply says if you made an investment that's earning a rate, if you just take the interest earned out every year, then what happens? You leave the principal intact, and assuming the fund earns that same rate, you have a plan that can run forever. All that you're doing is made an initial investment, then end of each year, you're just simply drawing the interest earned from that investment. If you draw the interest only, keep the principal intact, the next year you have the same situation. So now you got a scheme, an investment plan that runs forever. So following that, starting from year 5, the rate changes to 8%, increase to 8%. So 8% of the A prime, that's what I'll draw every year, and that happens to be 2,500. So A prime is 31,250. Putting it back in the first equation, to solve for X, and X is $33,888.26. So basically what you are saying here, that that an initial investment of $33,888.26 will support the recurring annual expenditure forever. So you can support an withdrawal of $2,500 forever with an investment of $33,888.26, where the investment earned 6% in the first 5 years and 8% thereafter. And this is an example of capitalized cost. Like I said, this module does two things: introduce effective rate, interest rate, and also talks about capitalized cost. I'll bring more problem later on capitalized cost. Hopefully you like the module. Thank you.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.